Hi students, welcome back to yet another session in matrices concept. In the previous session, we studied about symmetric and skew symmetric matrices, and we solved problem based on the symmetric and skew symmetric properties. In this session, we are going to study about the properties of symmetric and skew symmetric matrices. Okay, so let me recollect certain properties on symmetric and skew symmetric matrices. Let me recollect certain definition of symmetric and skew symmetric matrices. When we call a matrix as a skew symmetric matrix and symmetric matrix, a matrix A is said to be symmetric if A transpose is equal to A. If A transpose is equal to A, then matrix A is symmetric. When the matrix is said to be skew symmetric if A transpose is equal to minus A, then matrix A is said to be skew symmetric matrix. So these are the definition for symmetric and skew symmetric matrices. Okay. So if A transpose is equal to A, then matrix A is said to be symmetric matrix. If A transpose is equal to minus A, then A is said to be skew symmetric matrix. And we studied for any symmetric matrix, for any square matrix, for that case, for any square matrix A, we know that A plus A transpose is symmetric, and A minus A transpose is skew symmetric. And we did problems based on this concept in the previous video. Okay, so with this introduction, let us prove certain properties of symmetric and skew symmetric matrices. Now consider this property: A and B are symmetric matrices and AB equal to BA. They are given AB equal to BA. Then we are supposed to prove that AB is also symmetric matrix. A and B are symmetric matrices, and we are having the special condition AB is equal to BA. Usually matrix multiplication is not commutative, but in this particular problem, if AB equal to BA, then we can very well say that AB is symmetric matrix. So what are given now? Given A and B are symmetric matrices and AB equal to BA. What we are supposed to prove? To prove the product AB is also symmetric. That is, we must prove that AB whole transpose is also equal to AB. This is what we are supposed to prove. So we start with the proof. We start with AB whole transpose. By property of the transpose of the matrix, AB whole transpose is nothing but B transpose A transpose. It is the property of the transpose of the matrix. AB whole transpose is nothing but B transpose into A transpose. And it is given A and B are symmetric matrix. Because they are given to be symmetric matrix, we can clearly say that A transpose is equal to A and B transpose also equal to B. So we change this one to B transpose is written as B, A transpose is written as A. Why? Because A and B are symmetric matrices. Now another condition is also given to us. AB is equal to BA. So now I can write BA as AB. So what we conclude now? We can conclude AB whole transpose is equal to AB, which implies AB is symmetric matrix. Very simple proof. So here we are using the concept of transpose of a matrix as well as symmetricity of the matrices. Let us solve another problem. Now see this question. A, B and AB are all symmetric matrix. They have given. In that case, we must prove that AB is equal to BA. In the previous question, they are given A and B as symmetric matrix and AB is equal to BA, and we proved AB is symmetric matrix. Here A is symmetric, B is symmetric, AB is also symmetric. Using these three concepts, we must prove that AB is equal to BA. So what are the things given to us? Given A, B and AB are all symmetric matrix. So what we know about that? In that case, A is symmetric means A transpose is equal to A, B is symmetric, therefore B transpose is equal to B, AB is also symmetric. So AB whole transpose will be equal to AB. What we are supposed to prove? To prove AB is equal to BA. This is what we are supposed to prove. So we prove. We start with AB whole transpose is equal to AB. Why? Because AB is symmetric matrix. AB is symmetric matrix. Now what is AB whole transpose? Use the property of transpose of a matrix. By property of transpose of a matrix, AB whole transpose will be rewritten as B transpose A transpose, which is equal to AB. Right answer we are not going to touch. Left answer only we are going to do the simplification. Now what is B transpose? Tell me. What is B transpose? Yes, exactly. What is B transpose? B transpose is B. Why? Yes, B is a symmetric matrix. Since B is symmetric, B transpose is equal to B. Then what about A transpose? A transpose is equal to A. So we proved BA is equal to AB. Hence proved. Again, it is a very simple proof. Okay. Let us do another problem. Now, What is given? A and B are skew symmetric matrices now. A and B are skew symmetric matrix, and AB is equal to BA. AB is given to be equal to BA. Okay. Then show that AB is symmetric matrix. A and B are skew symmetric, but we are supposed to prove AB is symmetric matrix. And extra condition given here is AB is equal to BA. So first we write what is given to us. Given A, B are skew symmetric matrices. A and B are skew symmetric matrices. In that case, what we know about that skew symmetric matrix? A transpose will be equal to minus A, and B transpose will be equal to minus B. Why we are using minus symbol here? Because it is going to be skew symmetric. It is going to be skew symmetric. Because it is given to be skew symmetric, we use A transpose equal to minus A and B transpose also equal to minus A. And also one more condition is given to us. What is given? AB is equal to BA. What we are supposed to prove? To prove AB is symmetric. We are supposed to prove AB is symmetric. So what we are supposed to prove? To prove AB is symmetric. That is, we are supposed to prove AB whole transpose is equal to AB itself. This is what we are supposed to prove. So we start. We start with the LHS. What is your LHS? AB whole transpose. Again, use the concept of transpose of a matrix. We have already studied, correct? Transpose of the product is equal to product of the transposes taken in reverse order. Or in simple words, AB whole transpose is equal to B transpose A transpose. So it is equal to B transpose A transpose. But what is B transpose? B transpose is nothing but minus B. What is A transpose? A transpose is equal to minus A. So we rewrite B transpose is written as minus B and A transpose is written as minus A. Minus into minus, it is plus. So BA. And now we are going to use the idea of AB is equal to BA. We are going to use this idea. So BA can be written as AB, which is your RHS. So we proved AB whole transpose is equal to AB itself. Therefore, AB is symmetric matrix. So in this part, we have taken A matrix as a symmetric matrix and A is the skew symmetric matrix, B is also a skew symmetric matrix, and we are having the condition AB is equal to BA. In that case, the product AB is also symmetric. We proved it. Now same way, if A and B are skew symmetric matrices of same order and AB is symmetric matrix, then show that AB is equal to BA. We have proved with the help of symmetric matrix. Now we are going to prove with the concept of skew symmetric matrix. That is the difference. So A and B are skew symmetrics of same order. So given A and B are skew symmetric matrices. What do you mean by skew symmetric matrix? A transpose is equal to minus A, B transpose is equal to minus B. And one more condition is also given. What is given? AB is symmetric matrix. AB is symmetric matrix. So I make use of that concept. AB is symmetric. It is not skew symmetric. It is symmetric. That is AB whole transpose is equal to AB itself. We are not supposed to put minus symbol. Why? Because it is given very simple. It is a symmetric matrix. If it is a symmetric matrix, AB whole transpose will be equal to AB itself. No change. Okay. What we are supposed to prove? To prove AB is equal to BA. AB is equal to BA. So we start. Since AB is symmetric matrix, AB whole transpose will be equal to AB itself. Now again we are going to make use of the transpose of the matrix product. Transpose of the product of the matrix. AB whole transpose is equal to B transpose A transpose, which is equal to AB. Already we know B transpose is nothing but minus B. B transpose is nothing but minus B. A transpose is nothing but minus A, which is equal to AB. So minus B into minus A. Minus into minus, it will be plus. So BA is equal to AB. Hence proved. So we have taken matrix A and B as skew symmetric matrix, and AB, the product AB is going to be symmetric. In that case, we have proved AB is equal to BA. Commutative property holds good in the multiplication. Now consider this proof. If A and B are symmetric matrices of same order, okay, because with symmetric matrix it should be a square matrix basically, but they are going to be of same order. So in such case, we are supposed to prove that AB plus BA is also symmetric matrix. AB plus BA is also symmetric matrix. So given A and B are symmetric matrix. A and B are symmetric matrix. So what we know about the property? A transpose will be equal to A and B transpose will be equal to B. Okay. What we are supposed to prove? To prove AB plus BA is symmetric matrix. That is, we are supposed to prove AB plus BA whole transpose is equal to AB plus BA. Okay, this is what we are supposed to prove. How we are going to prove? If we know the basic concept, of transpose of the matrices and symmetric and skew symmetric matrices, we can easily prove the AB plus BA whole transpose is equal to AB plus BA itself. So we start with the LHS. What is your LHS? AB plus BA whole transpose. So by property of transpose of the matrix, this can be rewritten as AB whole transpose plus BA whole transpose. Is it clear? That is, if you are going to have A plus B whole transpose, we can rewrite this as A transpose plus B transpose. That's it. Very simple. Now we are going to use the property for the product of the transposes. So we are going to see transpose of the product. AB whole transpose. AB whole transpose will be rewritten as B transpose A transpose. Again, BA whole transpose will be rewritten as A transpose B transpose. Using the properties of symmetric matrices, B transpose will be written as B, A transpose will be written as A, plus A transpose will be written as A and B transpose will be written as B. Now matrix addition is commutative. Matrix addition is commutative. So we can rewrite this as AB plus BA, which is nothing but your RHS. So what we conclude now? We conclude that AB plus BA whole transpose is equal to AB plus BA itself, which implies AB plus BA is symmetric matrix. AB plus BA is symmetric matrix. Now we are going to see another important concept of symmetric and skew symmetric matrices. Okay, we know for any square matrix A, for any square matrix A, we know that A plus A transpose is symmetric. A plus A transpose is symmetric matrix. Okay, and A minus A transpose is skew symmetric. We already seen problems of proving that for any square matrix A plus A transpose is symmetric and A minus A transpose is skew symmetric in the previous video session. Okay, now using that concept of sum of square matrix and its transpose is symmetric and A minus A transpose is skew symmetric, we are going to write a very important formula. Any square matrix A can be written as sum of symmetric matrix and skew symmetric matrix. We can write any matrix that should be a square matrix. Any square matrix A can be written as sum of symmetric matrix plus skew symmetric matrix. So A can be written as, we know that A plus A dash is symmetric. Okay, I will add 1 by 2 plus 1 by 2 times A minus A dash. A dash is nothing but transpose of a matrix. Okay, if you want to write, you can write this as transpose. Is it clear? So any square matrix A can be written as sum of symmetric and skew symmetric matrix. Here 1 by 2 times A plus A dash is going to be symmetric matrix. This matrix will be symmetric matrix, and 1 by 2 times A minus A transpose always skew symmetric. Is it clear? So this we try to do it by writing A is equal to 1 by 2 times P plus 1 by 2 times Q, where P is equal to A plus A transpose and Q is nothing but A minus A transpose. So we use this formula to write any square matrix as sum of symmetric and skew symmetric matrices. Here P will be symmetric matrix and Q will be skew symmetric matrix. Now consider this problem. Express the following matrix as the sum of a symmetric and a skew symmetric matrices. Sum of symmetric and skew symmetric matrix. So we take the given matrix as A. A is equal to 3, 5, 1, minus 1. In that case, A transpose will be equal to, how to write A transpose? Writing row in terms of columns. So it is 3, 5, 1, minus 1. Now I am going to find the sum of these two matrices. Okay. So I am going to find P matrix. P is equal to A plus A transpose. Find A plus A transpose. A matrix is 3, 5, 1, minus 1. A transpose is going to be 3, 1, 5, minus 1. Is it clear? Now we are going to add these two matrices. When you add, because this first matrix is going to be a 2 by 2 matrix, the second one is going to be a 2 by 2 matrix, we can add the matrices. How to add? Add the corresponding elements. So add the first row first column with the first row first column. So it is 3 plus 3, then 5 plus 1, then 1 plus 5, then minus 1 minus 1, which is equal to 6, 6, 6, minus 2. So this is P matrix. Definitely this P matrix is a symmetric matrix. Is it clear? So find P dash. P dash is equal to 6, 6, 6, minus 2 transpose, which is nothing but 6, 6, 6, minus 2, which is equal to P. So clearly P is a symmetric matrix. Now I am going to find Q. How to find Q? Q is equal to A minus A transpose. A minus A transpose. So A matrix is 3, 5, 1, minus 1, minus of A transpose 3, 1, 5 minus 1. This is 3, 5, 1 minus 1 plus of, I multiply that minus symbol inside. I am changing this one to negative matrix. So minus 3 minus 1 minus 5 plus 1. So this is equal to, I add corresponding elements, 3 minus 3, 5 minus 1, 1 minus 5, minus 1 plus 1. When you simplify, the answer will be equal to 0, 4, minus 4, 0. Clearly you can see that Q is skew symmetric, but we try to prove. I try to find Q transpose. Q transpose will be equal to 0, 4, minus 4, 0. I am going to find the transpose of this matrix, which is equal to 0, 4, minus 4, 0. I take a minus symbol outside, so it is 0, 4, minus 4, 0. So Q transpose is equal to Q itself, correct? So Q is skew symmetric. Now my A can be written as A is equal to 1 by 2 times P plus 1 by 2 times Q, that is equal to 1 by 2 times P matrix, that is 6, 6, 6 minus 2 plus 1 by 2 times Q matrix. Q matrix is 0, 4, minus 4, 0. And I can multiply this scalar inside. I change this one to 3, 3, 3, minus 1. And I divide each element by 1 by 2 for the second matrix also. It is 0, 2, minus 2, 0. So by which the matrix A is written as sum of two matrices. One is symmetric matrix. The first one is going to be a symmetric matrix, okay, and the second one is going to be a skew symmetric matrix. So this is how we have to prove, or writing the given matrix, a square matrix, in terms of sum of symmetric and skew symmetric matrix. You can follow the same method to prove this problem, okay. You can try at home, okay. You can practice this problem. X plus this matrix 3 minus 4 1 minus 1. Try to write this one as sum of two matrices. One is symmetric matrix, the other one is skew symmetric matrix, okay. Now we move on to same type of proving the problem, but here it is going to be a 3 by 3 matrix. Here it is going to be a 3 by 3 matrix. So same question, X plus this matrix 3 2 5 4 1 3 0 6 7 as sum of a symmetric and skew symmetric matrix. Is it clear? So we have done problem with the 2 by 2 matrix. So we won't find any difficulty in proving the 3 by 3 matrix also. We take the given matrix as A. A is equal to 3 2 5 4 1 3 0 6 7. And we know how to write this matrix as sum of symmetric and skew symmetric matrix, because in the previous problem we have done it. So how to write? We are supposed to write this one as A is equal to 1 by 2 times P plus 1 by 2 times Q, where P is equal to, what is P? Symmetric matrix, correct? How to find that symmetric matrix? A plus A transpose, A plus A transpose. How to find Q? Q is obtained by finding A minus A transpose, and then you substitute in the formula. So this is the method we are going to follow to find it. Okay, so we start. So already we have written A. I am going to write what is A transposes. How to write A transpose? Write the row element as column element. First row element 3 to 5 is written as first column 3 to 5. Second row 4 1 3 is written in second column 4 1 3. So row is changed to column. Then 0 6 7. So I found out A transpose. I found out A transpose. Now I am going to find P. What is P? P is nothing but A plus A transpose. A plus A transpose. So I am going to find A plus A transpose. So 3 2 5 4 1 3 0 6 7 added with A transpose 3 4 0 2 1 6 5 3 7. So this is a 3 by 3 matrix. This is also 3 by 3 matrix. We can find the sum. How to find the sum? Add the corresponding elements. So I am going to add. I am going to skip one step. I am going to add. 3 is added with the 3. So 3 plus 3 is how much? 3 plus 3 6. 2 is added with 4. 2 when you add with the 4, again it is going to be 6. 5 added with the 0. 5. Next, second row first column 4 added with the 2. 4 plus 2, again 6. 1 plus 1, 2. Second row third element 3 added with second row third column element 6. So corresponding element added. So 9. Then 0 plus 5 is going to be 5. 6 plus 3 going to be 9. 7 plus 7 going to be equal to 14. So this is your P matrix, which is nothing but A plus A transpose. And I am going to prove that it is symmetric matrix. P is a symmetric matrix. So I try to find what is P transpose is. P transpose is nothing but, I write one step, 6 6 5 6 2 9 5 9 14 transpose, which is equal to, it is going to be again 6 6 5, first row written first column, second row 6 2 9 written in the second column 6 2 9, third row 5 9 14. You can very well see that there is no change for P. P transpose is equal to P, which implies P is symmetric. So we got the first component of this sum. I found out the first component, symmetric matrix. Next I am going to find Q. How to find Q? Q is nothing but A minus A transpose, that is A matrix. What is your A matrix? 3 2 5 4 1 3 0 6 7 minus of A transpose. A transpose is 3 2 5 4 1 3. This is your A transpose. Okay, 0, 6, 7. So I want to subtract. So for subtraction, I will do one more step. So I write 3, 2, 5. First matrix I write as such 4, 1, 3, 0, 6, 7. I change minus to plus and convert the second matrix to negative matrix. Convert the second matrix to negative matrix. How to find negative matrix of a given matrix? Multiply throughout by minus symbol. So by which this minus is transferred inside. So what you are going to get? Minus 3, minus 4, 0, minus 2, minus 1, minus 6, minus 5, minus 3, minus 7. So I am going to add. So I add first row with the first column. First row, first column with first row, first column. So 3 added with minus 3. What you are going to get? 0. 2 minus 4. Second element. Okay. Second element added with the second element. So 2 minus 4. 2 minus 4. Different symbol. So we have to subtract. So when you subtract, your answer is going to be minus 2. 5 plus 0. So it is going to be 5. Next. Second row first column element is added with the second row first column element. 4 minus 2. 4 minus 2 is 2. 1 plus of minus 1. 1 minus 1 it is 0. 3 minus 6. So it is going to be minus 3. Then 0 plus minus 5. So 0 added with the minus 5. It is going to be minus 5. 6 added with the minus 3. It is going to be 3. And 7 added with the minus 7. It is going to be 0. Clearly you can see that A minus, we have already proved it. A minus A transpose is skew symmetric. But we have to prove here also. It is going to be skew symmetric. So I try to find Q transpose. 0 minus 2, 5. 2, 0 minus 3. Minus 5, 3, 0. Transpose, which is equal to 0 minus 2, 5. Okay. 2, 0 minus 3. Minus 5, 3, 0. So I have transposed the matrix Q. This is, I take minus n outside. So it is 0 minus 2 plus 5. 2, 0 minus 3 minus 5, 3, 0, which is equal to minus Q, which implies Q is skew symmetric. Q is skew symmetric. The problem is not yet over. Okay. We are supposed to express A. So how to write A now? A is already given by the formula 1 by 2 times P. What is your P? P is this matrix. What is that? 6, 6, 5, 6, 2, 9, 5, 9, 14 plus 1 by 2 times Q symmetric matrix. Q matrix 0 minus 2, 5, 2, 0 minus 3, minus 5, 3, 0. Thus, we have written a square matrix as sum of symmetric and skew symmetric matrices. So, in this session, we have derived certain properties of symmetric and skew symmetric matrices, and we have written any square matrix in terms of symmetric and skew symmetric matrices. Okay. Thank you, children. We will meet in another session of applied mathematics. Thank you.